Good morning, children. Today I will start with the chapter Redox reaction. This is lecture 1 of chapter Redox reaction. What is a redox reaction? Redox means reduction plus oxidation. You can see the word redox. From this word redox, red stands for reduction and ox stands for oxidation. Both processes occur simultaneously. In a reaction, oxidation and reduction taking place simultaneously. Hence, one species is oxidized, another is reduced. So, what is oxidation and what is reduction? We will see three different definitions of oxidation reduction in the next slide. The definition of oxidation reduction, all of you know about it. Gain in oxygen, loss of hydrogen and loss of electron. This is oxidation. Loss of oxygen, gain in hydrogen and gain of electron, they all are reduction. Now here are certain examples. In terms of oxygen, oxidation means you have seen that it is gain of oxygen in a species. So Mg is oxidized to MgO. That means oxygen is added to magnesium. Reduction in terms of oxygen, loss of oxygen in a species. H2O is reduced to H2. That means oxygen is removed. So what we can see that O is added and O is removed. So it's the gain or loss of O, not O2 minus. Please remember that. Now oxidation reduction in terms of hydrogen. As you know that loss of hydrogen is oxidation. See the example, H2O is oxidized to O2. Reduction, gain of hydrogen. O2 is reduced to H2O2. It's gain or loss of H and not H plus. Oxidation reduction in terms of electrons. It is given by the word oil rig. Oil means OIL means oxidation is loss. And you know that it is electron. So oxidation is loss of electron. That means oxidation. O means oxidation, I for is and L for loss of electron. And rig means reduction, R for reduction, is, I for is, G is gain and of electron. Easy to remember? Now see here, loss of electron is oxidation. Mg is oxidized to MgO. Mg from 12 electron to 10 electron. That means if I'll write like this, Mg is now forming MgO. Now you can say this is an oxidation because oxygen is adding. But I want to tell this in terms of electron transfer. So that means it is loss of electron. That is oxidation. So Mg is having 12 electron. You all know that it is having 12 electron. Now if we'll check here, now this is having 10 electron because this is forming Mg 2 plus and O2 minus. Okay, that means it is Mg2 plus, and Mg2 plus is nothing but 10 electron. And this is actually Mg0. So this is having 12 electron, and this is 2 plus. So it is having 2 plus, magnesium 2 plus. Magnesium 2 plus means it is having 10 electron. So it's a loss of electron. Am I clear? Now reduction is gain of electron, that you know. O2 is reduced to H2O2. Now O from 8 electron, I'm saying about only one oxygen. O from 8 electron to 9 electron. It is coming here 9 electron. In H2O2, the electron of O is 9 because one oxygen with one hydrogen. Okay, so it is 9 reaching from 8 electron to 9 electron. So that is a reduction, gain in electron. Okay, per oxygen, per one oxygen, it is 9. H2O2 per oxygen, it is 9 here. So from one oxygen that is having 8 electron, it is reaching to 9 electron. So this is a reduction, gaining of electron. Oxidation and reduction in terms of oxidation state. It's a new thing for you, oxidation state. Now, the concept of oxidation state. What is the oxidation state or oxidation number? Now, you know that always we are saying that Fe, iron, we are getting iron in two form, Fe2 plus and Fe3 plus. You know that this is the ferrous and this is ferrous and this is ferric form. That means we are saying that iron is having variable valency, but that is true for smaller children. Okay, now you have to think in some other way. That means Fe2 plus, if you are taking ferrous salt and if you are keeping it sometime open in the atmosphere, it will change to Fe3 plus, that is ferric. That means what? Oxidation is going on. Because of the atmospheric oxygen, it is oxidized and ferrous will change to ferric. That means what? Oxidation state is changing. It is from Fe2 plus, it is going to Fe3 plus, and that is oxidation state. Okay. Now, if I'll say that the valency of oxygen is 2, it means that it is only the combining capacity of oxygen. If I'll say the valency of oxygen is 2, that means oxygen can hold two other elements. You cannot say that the valency of oxygen is +2 or -2. It is only the combining capacity. It can hold two other elements without sign. So valency is not having a sign, but oxidation state is having a sign. From this oxidation state, oxidation number is coming. Okay, now oxidation state, that means oxidation number. In terms of oxidation state or oxidation number, we can define oxidation and reduction also. Now oxidation is gain in oxidation state. That means increase in oxidation number. In the following slides, you will see that. Oxidation is gain in oxidation state. So that means it is gain in oxidation state. Fe2 plus, it is going to Fe3 plus. So it is gain in oxidation state. So that means it is oxidized. It is oxidation. This example is an example of oxidation. Am I clear to you? Magnesium is oxidized to MgO. In this reaction, magnesium is going to MgO. Now, if I want to write it in the oxidation number of this, in the following slides, you will come to know how to calculate the oxidation number and how to know the oxidation number of a particular element. But here just I'm telling you the oxidation number. Okay, oxidation number of any element which is uncombined is 0. This is the oxidation number. Now, oxidation number of oxygen is -2. Now with the sign. So oxidation number of magnesium is how much in this compound. Now magnesium, how to calculate? Suppose magnesium is X and oxygen is having -2. That means it will be plus and -2. And as it is a neutral molecule, it is equals to 0. So from there, magnesium, that means X -2 is equals to 0. So X is equals to +2. So I'll write here +2. So just see that magnesium is changing from 0 to +2. That means oxidation number increasing. So it is oxidation. You will get a clear idea about it in the following slides. Don't worry about it. Okay. Similarly, reduction is gain of electron, or you can write here decrease in oxidation number is known as reduction. Now here the example is given, O2 is reduced to H2O2. Now see that O2 is reduced to H2O2. How it is reduction? Now O2, it's a molecule. It is uncombined. It is in the 0 oxidation state. Now in this H2O2, the oxidation number of O2 is, how to calculate? I'm just telling you that hydrogen, the oxidation number of hydrogen is +1. Now this is 2 hydrogen atoms, so it will be +2. And this is 2 oxygen, so I will write here 2x is equals to 0. So from there, 2x is equals to -2, or x is equals to -1. Okay, but as so it will be here, it will be -1, the oxygen. So that means it is changing from 0 to -1. Okay, so that means it is decrease in oxidation number from 0 to -1. So it is decrease in oxidation number. So this is reduction. Okay, don't get confused. In the next slide, you'll get a clear picture about it. Now, note, oxidation state are always written in +x or -x. That means it should have a sign. Without sign, oxidation number is not written. Valency without sign, but oxidation number is having a sign. Never just x or x minus, not like that. Oxidation state of Mg in MgO is +2, not 2 or -2 or -2. No, not that. It is having a particular sign. Now, if a reaction is written in the ionic form or a molecular form, the oxidation and reduction in both the cases can be shown with the help of electron transfer. See, in the first equation, it is an ionic form of equation. Now, here in this equation, you can see that zinc is going from 0 state to +2 state. That means there is a loss of 2 electrons. From Zn 0, it is going to Zn 2 plus. That means it is Zn 0 minus 2 electron. So it is giving you Zn 2 plus. That means loss of 2 electron. So it is oxidation. And here it is H plus to H2. That means it is going from H plus to H2. That means there is 2H. So it is again it is 2H plus, and this is 0 state. So 2H plus is now gaining 2 electron. It is going to H2, that is 0 form. Okay, that means gain of 2 electrons. So it is reduction. Am I clear? Now similarly, see for the molecular equation, here Sn2 plus, it is going from Sn2 plus to Sn4 plus. Okay, so that means that Sn4 plus, here it will be Sn4 plus. It is going from Sn2 plus to Sn4 plus. That means it is from +2 to +4 state. Okay, so it is oxidation. And this is +3 to +2 state. So it is reduction. Okay, gain of electron for Fe and loss of electron for Sn. So this is oxidation and this is reduction. Oxidizing and reducing agent. An oxidizing agent is a chemical species that causes the other reactant in a redox reaction to be oxidized. Oxidizing agent is helping the other species in a redox reaction to be oxidized. So it is always reduced in the process. Oxidizing agent is oxidize someone else, so reduce itself getting reduced. And a reducing agent is always reducing someone else, so itself getting oxidized. So what is said? An oxidizing agent is itself reduced when it oxidizes something. A reducing agent is itself oxidized when reduces something. 2 Mg plus O2 is giving you 2 MgO. In this, Mg is oxidized and thus is a reducing agent. And O2 is reduced and thus is an oxidizing agent. Is it okay? Now see, working rules for determining the oxidation number of an atom. These rules you have to learn and it will come automatically. Okay. The first rule is oxidation number of all elements in the elementary or uncombined state is 0. Oxidation number of hydrogen in H2 is 0. Oxidation number of helium is 0. Oxidation number of nitrogen in N2 is 0. Oxidation number of phosphorus in P4 is 0. They all are in elementary state or uncombined. It is not combined with anything. They are free. So their oxidation number is 0. Number 2. The oxidation number of an element in a monoatomic ion is equal to the charge present on the ion. Suppose the oxidation number of Na in Na plus. If it is Na plus, that means plus only one charge. So its oxidation number is plus 1. Oxidation number of Fe in Fe2 plus is 2 plus. Oxidation number of Sn in Sn4 plus is 4 plus. Oxidation number of S in S2 minus is minus 2. Similarly, oxidation number of chlorine in Cl minus is minus 1. Okay. Oxidation number of fluorine in all of its compound is minus 1. Automatically this thing will come, children. You need not to work very hard for remembering all these things. Number 4 rule. The oxidation number of alkali metal, lithium, sodium, potassium, rubidium, cesium and francium is plus 1 in all their compounds. And the oxidation number of alkaline earth metal, that is beryllium, magnesium, calcium, strontium, barium and radium, is plus 2 in all of their compounds. It is, you can think that it is similar to that of the valency, but it is not the valency. Valency is without sign. It is only the combining capacity. Okay. The number 5 rule. The oxidation number of hydrogen in all of its compound except hydride. Hydride means sodium hydride, potassium hydride, all this. Except hydride, the oxidation number of hydrogen is plus 1. And in hydrides, that is potassium hydride, CaH2, etc., the oxidation number of hydrogen is, it will be minus 1. It will be minus 1, not plus 1. It will be minus 1. I am writing here once again. Okay, this is not. Next is number 6. The oxidation number of oxygen in most of its compound except peroxide, superoxide, suboxide is minus 2. Okay. In peroxide, H2O2, Na2O2, BaO2, the oxidation number of oxygen is minus 2. In peroxide, okay, that is minus 2. The oxidation number of oxygen in superoxide, KO2, and suboxide, C3O2, depends upon the nature of the compound. Exceptions also occur when oxygen is attached to a more electronegative atom. For example, in compounds like OF2, O2F2, the oxidation number of oxygen are plus 2, plus 1 respectively. So this is not so important. You need not to know about it. Generally, you will get oxidation number of oxygen is minus 2. Okay, you need not to worry about it. 7. The algebraic sum of oxidation number of all atoms in a neutral molecule is 0. This is very important rule. It will come again. Just see that in H2O, example you see H2O, the oxidation number of hydrogen, as I told you, the first rule is H1 plus 1, and oxidation number of O is minus 2. Okay, so sum of the oxidation number is equal to, this is, see that H2O, I am writing here, just look at what I am writing. H2, one hydrogen is 1 plus 1, I am having 2, so I can write here 2 into plus 1. And plus, all have to be added. Plus, oxygen, you know that the oxidation number of oxygen is minus 2. I'm keeping it in the bracket -2, and that equals to 0. That should come equal to 0. Now you check this one. 2 ones are 2. That means it is +2. And this is plus minus -2. This is also coming to 0. Am I clear? And that is why it is written that the algebraic sum of oxidation number of all the atoms in a neutral molecule is 0. It is automatically will come 0. In case of H2SO4, it is shown here. I'm just writing here H2SO4. Okay. Now, oxidation number of hydrogen is +1. You know, I'm having 2. So, it is 2 into +1. Now, sulfur is having the oxidation number +6. So, you can write here +6. Then again plus, we are having 4 oxygen and each oxygen is having the oxidation number -2. So I'm having 4 into -2. Now let me check whether the addition of all is giving 0 or not. 2 ones are 2, that means +2, +6, plus minus -8. This is +8. -8. This is coming to 0. So, this rule is fulfilling this. The algebraic sum of oxidation number of all atoms in a neutral molecule is 0. Now, number 8. The algebraic sum of oxidation number of all atoms in an ion is equal to the charge present on that ion. Suppose like this, the first one, OH minus. How we will write it? O is -2, you know. And the oxidation number of hydrogen is +1. So there will be plus bracket +1. So this should come -1 because the charge in -1. So it should come -1. Now let me see, -2 plus 1. This is also coming to -1. Is it okay? Now see for SO4 2 minus. SO4 2 minus. Sulfur, I told you that +6. Now oxygen, each oxygen is -2. I'm having 4. So I can write here +4 into -2. It should be equal to -2 because the charge is -2. The law is saying this. So this is coming +6 plus minus 2 fours are 8. And this is coming to -2. See, my left hand side is equal to right hand side. Okay. Now, rule-based determination of oxidation number, in that with the help of these rules, oxidation number of an atom in a molecule or ion can easily be determined. Following example illustrate the procedure. Calculate the oxidation number of the underlined element in the following molecules. The first one is H2SO4. Now children, I'll explain how to calculate the oxidation number of the underlined element with the help of the rules. The first one is given, find the oxidation number of sulfur in H2SO4. Now these questions are very important, children, and this definitely will come in the exam. You can see that H2SO4 is a neutral molecule. And the rule number 7 is saying the algebraic sum of oxidation number of all atoms in a neutral molecule is 0. Please go back and see the rules once again. Now, as you know that hydrogen is having oxidation number +1. and we are having 2 hydrogen here. So I can write it as 2 into plus 1. I have to find out the oxidation number of sulfur. Let me just take it as X, plus X. Then again plus, you know that the oxidation number of oxygen is -2 and we are having 4 oxygen atoms. So I can write it 4 into -2, and as it is a neutral molecule, the sum of all the atoms will be equal to 0. Okay, now solve this, you will get the value of X. Now this is 2 ones are 2, that means plus 2. Please write with the sign. Now plus X plus minus -8 is equals to 0. Now plus 2 minus 8 is -6, plus X is equals to 0, or X is equals to plus 6. So oxidation number of sulfur in H2SO4 is plus 6. Write the answer with the sign. Repeatedly I am saying this. Number 2. Number 2 question is given KMnO4. Please go back and see the question. Mn is underlined. Now again it is a molecular equation. Neutral molecule. It's a neutral molecule. So the sum of all the atoms will be 0. Sum of the oxidation number of all the atoms will be 0. So potassium is the alkali metal. Its oxidation number is plus 1. See the rules. Magnesium we have to find out. Manganese. So manganese is plus X. Then oxygen is -2. I am having 4. So plus 4 into -2, and this is a neutral molecule, so which will be equal to 0. This is plus 1 plus X minus 8 is equals to 0. So X minus 7 is equals to 0. X is equals to plus 7. So the oxidation number of manganese in KMnO4 is plus 7. Clear? See question number 3. This is given HNO3. HNO3, you have to find out nitrogen, oxidation number of nitrogen. Hydrogen is plus 1 plus X. This is oxygen is -2. 3 are there, so it will be -6 is equals to 0. Now X minus 5 is -6 is equals to 0. So X is equals to, X minus 5. X minus 5. This is X minus 5 is equals to 0 and X is equals to plus 5. So the oxidation of number of nitrogen in HNO3 is plus 5. Now see question number 7. Question number 7 is Na2S4O6. Na2S4O6. Okay, here you have to find out the oxidation number of sulfur. Now, how to do this? Na2, sodium is alkali metal. So this is oxidation number is plus 1, but I am having 2 sodium. So it will be plus 2. Okay, I am writing in one step only. Now S4, let the oxidation number of sulfur is X. And I am having 4 sulfur atom. So it will be 4X. Don't do mistake, it will be 4X. Now 1 oxygen is minus 2. I'm having 6 oxygen. So it will be 6 2s are 12 minus 12 is equals to 0. Now minus 12 plus 2, it will be minus 10 plus 4x is equals to 0, or 4x is equals to plus 10. X is equals to plus 10 by 4. So this is equals to plus 5 by 2. So oxidation number of sulfur in Na2S4O6 is 5 plus 5 by 2. Oxidation number can come in fraction. Don't worry. Okay, it can be a fractional number also. And rest, the questions what is given here, I'm giving you as homework. Please try to do those questions. Find out the oxidation number of the underlying element. Now, rule based for determination of oxidation number of the ions, if the ions are present. How to do that? Calculate the oxidation number of underlying element in the following ions. I'm just showing you here. Suppose number 3, S2O3 2 minus. How to do it? I have to find out the oxidation number of sulfur. Again, let the oxidation number of sulfur is X. So I'm having 2 sulfur atom. So it will be 2X. Oxygen is 1 oxygen atom is minus 2. I'm having 3 oxygen atom. So it will be minus 6 is equal to the charge present in it, that is minus 2. Okay. There's a rule saying, now this is 2x is equals to minus 2 plus 6. So 2x is equals to plus 4. X is equals to plus 4 by 2, that is plus 2. So oxidation of number of sulfur in S2O3 2 minus ion is plus 2. Clear? Now I am showing you number 5. MnO4 minus. You have to find out Mn, oxidation number of Mn. Now let it is X. Oxygen is minus 2. It will be minus 8 is equals to minus 1. Because the charge is minus. So minus 1. Now X is equals to minus 1 plus 8, or X is equals to plus 7. So oxidation number of manganese in MnO4 minus is plus 7. One more I am showing you. Suppose I am showing you the last one, 7th number. ClO minus. You have to find out Cl. X, 1 oxygen only. So it will be only minus 2 is equals to minus 1. Okay. Now X is equals to minus 1 plus 2. So X is equals to plus 1. Now see, the oxidation number of chlorine here is plus 1. So there is a difference between the valency and the oxidation number. Have you understood? So oxidation number always you have to write with the sign. Now the rest of the question you find out. And the questions that I am doing, that also you will copy in your notebook. Now to calculate the oxidation number of underlying elements in the following species. The first one, that is K4 FeCN whole 6. Number 1. K4 FeCN whole 6. And you have to find out the oxidation number of Fe. Now you know that potassium is the alkali metal, so its oxidation number is +1. So we are having 4 potassium atom, so it will be 4 into +1. And you have to find out Fe. So for Fe, let us take it X. And I am telling you the oxidation number of Cn is -1. So we are having 6 atom of Cn. So it will be 6 into -1. And it is a neutral molecule. So it's equal to 0. Now just solve it. +4 plus x minus 6 is equals to 0. X minus 2 is equals to 0. X is equals to +2. So in this compound, the oxidation number of Fe is +2. Am I clear? Now for second, third and fourth, I am doing it in the next slide. Number 2. Number 2 is FeH2O whole 6. FeH2O whole 6 Cl3. You have to find out the oxidation number of Fe in this compound. Now, Fe is X plus H2O. The oxidation number of H2O is 0. I am telling you why. Let us take it 0 into 6. And you know that oxidation number of chlorine is -1. We are having 3. So it will be +3 into -1 is equals to 0. So it is X plus 0 minus 3 is equals to 0. X is equals to +3. So oxidation number of iron in this compound is +3. Now why the oxidation number of H2O is 0? Just see here. Hydrogen is +1. We are having 2 hydrogen atoms, so it will be +2. And we know that oxygen atom, the oxidation number is -2. So +2 minus 2 is 0. So water, the oxidation number of water is 0. Number 3. The compound number 3 is KAgCN whole 2. KAgCN whole 2. And you have to find out the oxidation number of Ag. Now K, you know that it is +1. Ag is X plus Cn is -1, you know, and 2 Cn, so it will be 2 into -1 is equals to 0. So what I am getting? +1 plus X minus 2 is equals to 0. So X minus 1 is equals to 0. X is equals to +1. So oxidation number of silver in this compound is +1. The last one, that is number 4. The compound is CO NH3 whole 6 bracket 3 plus. You have to find out CO, the oxidation number of CO. Okay, now how to find out that? This is X plus Ammonia is a neutral molecule, so its oxidation number is 0. So it will be 0 into 6 is equals to plus 3. The charge is plus 3 for the whole compound. So X plus 0 is equals to plus 3. X is equals to plus 3. So oxidation number of cobalt in this compound is plus 3. Okay. So like that you have to find out the oxidation number of a particular element in a compound. And these all are very important. Now this is redox reaction in terms of oxidation number. A redox reaction involves the change in oxidation number of the species. Now, by seeing the change in the oxidation number in a reaction for a particular species, we can say that which element has undergone oxidation and which has undergone reduction. That already I told you. Now, gain in oxidation number is oxidation and decrease in oxidation number is reduction. Increase in oxidation number is oxidation and decrease in oxidation number is reduction. Okay. Now, suppose I am having a reaction Zn plus CuSO4 is giving you ZnSO4 plus Cu. So, first of all, we will write the ionic equation. Now, Zn from CuSO4, SO4 2 minus, so Cu2 plus. Okay, so I have written Cu2 plus. Now ZnSO4, SO4 2 minus and Zn is 2 plus. So I have written Zn2 plus and then Cu. This is just to show you I have written it separately, the ionic form. But when you will do the reaction in this state molecular form also, you can write the oxidation number at the top. Now, oxidation number and oxidation reduction process involves this reaction are as follows. This is from zinc to Zn2 plus, it is going. Now, zinc solid is oxidation number having 0. Okay, now Zn2 plus is having oxidation number plus 2. Okay, now this is from 0 to plus 2, that means increase in oxidation number. Okay, so this is oxidation. And this is Cu2 plus, from here it is going to Cu. From Cu2 plus to Cu. So that means Cu2 plus 2 and Cu is 0. So that is from plus 2 to 0 it is going. That means it is decrease in oxidation number is reduction. So it is only showing here that what I have told you just now. During the oxidation of zinc solid into Zn2 plus aqueous ion, the oxidation number is increased from 0 to plus 2. On the other hand, the reduction of Cu2 plus aqueous into Cu solid, the oxidation number is reduced from plus 2 to 0. Similar trends are observed in all oxidation reduction processes. Hence, the term oxidation reduction can be defined in a different way in terms of oxidation number. The new definition in terms of oxidation number are given below. That means in the next slide. Redox reaction. A reaction is said to be a redox reaction if the species involved in it undergo a change in oxidation number. That means in a particular reaction, oxidation reduction both should be there. If it is not there, if the oxidation number is not changing for a particular species, that means that is not a redox reaction. For example, following reaction can be regarded as a redox reaction because the species involved in it undergo a change in oxidation number. This one, you just see, look at this one. NaBr, it is going from, Br is -1 because Na is +1. So it is forming Br2, that is Br molecule. So it is going from -1 to 0. That means it is increase in oxidation number, -1 to 0. So it is undergoing oxidation. Bromine is undergoing oxidation. Now this is Cl2 to NaCl. Now change in oxidation number. You just see Cl minus is 1 and Na is +1. Now Na, there is no change in the oxidation number. Na is +1 to +1. See in the left hand side also +1, right hand side also +1. So I'll not take Na into our consideration. Cl2, that means it is a chlorine molecule. So it is 0, chlorine gas, it is 0. It is coming from 0 to -1. That means decrease in oxidation number. So this is a redox reaction. This is a redox reaction. But if I'll talk about this reaction, NaCl plus AgNO3, NaNO3 plus AgCl. Now you see, in the left hand side sodium is +1 because Cl is -1. So I'll write all the charges, that is +1, -1. This is +1, NO3 is -1. Na is +1, NO3 is -1. Ag is +1, Cl is -1. Now you see the change in the oxidation number. Na is +1, here also Na is +1. Cl is -1, Cl is -1. Ag is +1, here also Ag is +1. NO3 is -1, here in the right hand side NO3 is -1. Okay, so that means there is no change in the oxidation number in this particular reaction. So this is not a redox reaction. This is just a double decomposition reaction. This question is coming in the exam, whether the following reaction is a redox reaction or not. I think you have understood. So as I told you, oxidation is the process in which a substance undergo an increase in the oxidation number. See here, 0 hydrogen, from 0 it is going to H+, so it is +1. It is going from 0 to +1. And how to balance it? By adding 1 electron. So oxidation number increased from 0 to +1, so it is undergoing oxidation. Fe2 to Fe3. So how it is forming? How it will again form Fe2 plus? By adding 1 electron. So 2 plus to 3 plus, it is increase in oxidation number. So this is oxidation. Reduction is a process in which a substance undergo a decrease in the oxidation number. You just see Cu2 plus, it is going to Cu plus. That means +1. So that means +2 to +1. How it will form +1? By adding 1 electron this side. So this is decrease in oxidation number. So this is undergoing reduction. Sn4 plus to Sn2 plus. Decrease in oxidation number. So this is reduction. Oxidizing and reducing agent. An oxidizing agent is a substance which undergo a decrease in the oxidation number. An oxidizing agent is a substance which undergo a decrease in oxidation number of one or more of its element, whereas a reducing agent is a substance which undergo an increase in the oxidation number of one or more of its element. For example, see this reaction, H2S plus HNO3, NOS and H2O. Now write all the oxidation number. For all the species, write the oxidation number. Now you see that nitrogen here, it is right hand side from +5 to left hand side it is going to +2. That means decrease in oxidation number. Now you see sulfur in the left hand side it is -2 and the right hand side it is going to 0. That means -2 to 0 increase in oxidation number. That means it is undergoing oxidation. In this reaction, oxidation number of sulfur coming from H2S increases from -2 to 0, while that of nitrogen, which is coming from HNO3, reduce from +5 to +2. Therefore, H2S is the reducing agent. H2S is the reducing agent, while HNO3 is the oxidizing agent. I think you have understood this. Now, redox reaction in terms of oxidation number, how to see which one has undergone oxidation reaction, reducing agent, oxidizing agent. The first example is MnO2 plus aluminium is giving you Mn plus Al2O3. You have to identify oxidation, the substance undergoing oxidation, the substance undergoing reduction, oxidizing agent and reducing agent. See the solution. Now here write down the reaction first and then write down all the oxidation number. Okay. How to find out the oxidation number that you know. Suppose you want to find out MnO2. How we will write the oxidation number? MnO2. You have to write the oxidation number. You know the oxidation number of oxygen is -2 and we are having 2 oxygens. So write only one, that is -2. But while calculation you take this 2 also. Okay. Now if it is difficult for you to calculate, then write it in another place and do it. And it will automatically, you can write it in due course of time. Don't worry about it. So manganese is X. I am having each oxygen atom is having -2 oxidation number and I am having 2 oxygen atom. So it will be -4 and this will be equals to 0 because it is a neutral molecule. So X is equals to +4. That means, see here, that is manganese is written +4. So I will write here +4. Like this, you have to find out. Now, aluminium, uncombined state, it is 0. It is 0. Manganese, uncombined state, it is 0. Now, Al2O3, again you have to find out. Because Al2O3, suppose you are having Al2O3, you know that oxygen is -2. You write here -2. And just calculate it. It is -6. So it will be 2. That means 2x. And this is 3 2s are 6. That means -6 is equals to 0. So x is equals to +6 by 2. So x is equals to +3. So you can write here as +3. Just see, +3 is written. Okay. Now you see that manganese is +4 to 0. That means there is a change in the oxidation number. So +4 to 0, that means decrease in oxidation number. So it is undergoing reduction. Okay. So the first question, that is the substance undergoing reduction, you have got it. Next, you see aluminium from 0, it is going to +3. That means increase in oxidation number. So aluminium is undergoing oxidation. Okay. So the first, this part and this part you have got. And you see for oxygen, it is -2, -2. So there is no change in the oxidation number. We will not consider it. Now from the above, it is clear that the oxidation number of aluminium increases from 0 to +3. Hence, aluminium undergoes oxidation and act as a reducing agent. Okay. And in MnO2, the oxidation number of Mn decreases from +4 to 0. So therefore, MnO2 undergoes reduction and it is acting as an oxidizing agent. Clear? The second question, Cr2O7 2 minus, Fe2 plus, 14H plus, Cr3 plus, Fe3 plus and H2O. Write down the oxidation number of all the species. Now again there will be a problem how to write Cr2O7 2 minus. You have to find out Cr2, that means it will be 2x. I have to find out, I don't know the oxidation number of chromium. So 2x. Now here I am having 7 oxygen and each oxygen is having 2. So it will be minus 14 is equals to, it is an ionic compound. So the charge will be minus 2, equal to minus 2. Now 2x is equals to plus 12. Take 14 to that side. Now x is equals to plus 6. See, it is written plus 6. Okay. Now Fe2 plus is given. So its oxidation number is the charge plus 2. Now 14H plus. So its oxidation number is plus 1. I'll not take the 14. Now Cr3 plus. Now it is given here plus 3 charge. So it will be plus 3. Now here Fe is plus 3, so its oxidation number is plus 3, and H2O they have written, but H2O is 0 because oxygen is minus 2 and H2, this is plus 1 for 1 hydrogen and 2 hydrogen, so it will be plus 2, so it will be 0. So if you will not write for H2, no harm. Okay. Now see here, the chromium plus 6, it is reaching to plus 3. From plus 6, it is reaching to plus 3. That means decrease in oxidation number, so it is reduction. Okay. Now Fe from plus 2, see this is plus 2, it is reaching to plus 3. That means increase in oxidation number, so it is oxidation. Now which is undergoing oxidation, that is the reducing agent, and the species which is undergoing reduction, that is an oxidizing agent. So it is clear from the above that oxidation number of Fe2 plus ion increases from plus 2 to plus 3. Therefore Fe2 plus ion gets oxidized and acts as a reducing agent. In Cr2O7 2 minus ion, the oxidation number of chromium decreases from plus 6 to plus 3. Hence Cr2O7 2 minus ion gets reduced and acts as an oxidizing agent. I think it is clear to you now. Now this is the end of lecture 1. The next lecture will be on balancing the redox reaction.